Today we are going to talk about waste to energy topic, which is very interesting, as well as landscape planning and basically how to plan for future better. Our today's expert, Vasco, I will introduce him a little bit later, prepared very interesting slides for you. But before we jump into the topic, I wanted to make a few important announcements. So the first one is that we are recording this webinar, as you probably noticed already. We want to save it for future, for as many people to see it as possible. So it's going to go to our project's YouTube channel, and the project that I will be promoting a little bit today. It's called Local GoGreen, supported by European Union. You can find more information about us, about events we organize on our website, which is, I think, is the same, Local GoGreen. So this series of webinars, Go Green Tuesdays, are also part of it. And we are very happy there is interest and people are joining. So thank you so much for finding time to join us today. So the first announcement, this is recording. This session is being recorded. I hope you don't mind. And the second announcement concerns the um, translation and yeah, I guess that's the right way to put it, because we are using Wordly tool that help us translate the webinars speech, let's put it this way, into a list of endless languages. So I'm sure you can find your language on the list. I will just activate it in a second. And for that, I need to stop sharing my screen. I'm very sorry. So I will just activate this Wordly app so that you all get access to the translation. And I will just share it with all the current participants. So you should be able to see a little pop-up on your screen, I think in the right corner or just on top, that will offer you activate Wordly, and then you can select the language and basically we hope that it helps you follow the contents of today's session easily. So moving on, I wanted to invite you to join us next Tuesday for our last session of Go Green Tuesdays webinars. Unfortunately, we reached to the last session already. We had 6 of them in total. So the last one is dedicated to financing. So if you got inspired, by everything that you heard today and maybe in our previous sessions, and you wonder where to find money to implement all these changes, or what financial opportunities you can have, what financial support from European Union you can apply to, what are different financial mistakes you can do at the beginning, how to avoid them. Please join us next Tuesday. We will talk exactly about that. We have our wonderful expert, Guillermo, who is a very experienced consultant on this topic and our project partner. And yeah, just scan the QR code that you see on the screen. The registration is already open, and join. But before talking about plans for next week, I actually want to introduce our today's speaker, Vasko Plevnik, who is our expert from Croatia. He's project manager at Enercon. He is an engineer specializing in process, technical, and environmental aspects of energy and waste management. So, perfect profile for today's session. His expertise includes combustion technologies, energy balances, water and flue gas treatment, and the systems that I don't even know what's the correct way to pronounce. So I will leave it to Vasco and yeah, please prepare your questions. If you want to double check anything with him, if you have any follow-up questions to what Vasco will mention today, please write them down to our chat. And at the end of today's webinar, we will have a short Q&A session. So uh, let's uh, let's discuss it later. And now I will give the floor to Vasco.
Hello, everybody. I hope you can hear me well,
Yes.
and you can see the
Yes.
Ja,
first
ja, nee.
slide. So, today we have two major
Te pa
topics
daj, prosim.
that
Ok, pa me pošlje pa to.
uh,
Ok.
just we have two major topics that I will talk about. The first one is waste to energy, and the second one is land use planning for increased carbon absorption. Uh, so the agenda looks like this. Of course, my narrow field of expertise is waste to energy. Although there are only 3 points, we'll be speaking a little bit more about waste to energy. So, regarding the waste to energy, I divided it basically in four four bullets about the technology, about the society. We'll see more about that, and regarding the financing, and of course the conclusions. So, technology is simple. Yes, technology is available and in Europe functioning since the 1970s and 80s. The big difference from the first early plants to today plants is about the environmental impact. Of course, a lot was unknown at that time, and basically what the core concept hasn't changed, but the legislation and the emission limits have changed. So the technology adopted, which is normal, because with each step there is an improvement in technology, and of course, in the future the limits will be more strict, and the technology will adapt. That's something which normally happens. Uh, so the first part in technology is legislation. Basically, in EU, everything is driven by the Industrial Emissions Directive, which covered the Waste Incineration Directive and IPPC Directive. Uh, the Waste Framework Directive came in at a similar time and basically gave all the necessary steps which need to be followed in order to, on the end, implement energy recovery. There is never a possibility to avoid landfilling, but the whole idea is to reduce landfilling as much as possible and to remove every useful material from the landfill. The idea is not to do the energy recovery for all the materials that can be used in the waste to energy plants, but to reduce that material and extract the most materials that can be easily recycled. So, one very important part is the emission controls. With each round of increasing the and lowering basically the emission limits, the technology needs to follow in order to be compliant and in order for it to function. Just a second. Basically, it always starts from the combustion. Combustion control is the main source of the emissions, and over the time, the simulations, the experience allowed the combustion control to be improved. So the follow-up steps in waste-to-energy plants can adopt much easier. Over the years, flue gas cleaning has improved significantly. There are various types of flue gas treatment procedures from dry, wet, semi-dry, but the core idea is to remove the fine dust particles, to reduce the acidic particles below the limits, to reduce the NOx particles through DeNOx systems, and what is mandatory for all waste-to-energy plants since 2010 is to have continuous emission monitoring, which is basically ensuring that the plant is operating good. In case of failure of in case of failure of emission monitoring systems, plants are required to go to shutdown until that is repaired. Uh, Limits. Emission limits are stricter, not with each year, but with each round of changes in the legislation. And for most of the modern waste-to-energy plants, those have lower lower amount of pollutant particles than some cities and urban areas in Europe. Of course, one aspect is the environment, but the other aspect is efficiency. Over the years, uh, as the whole technology and the construction of the plants, the cost was increasing, there was more and more pressure to increase also the efficiency of the plants. So the first plants were used as power plant only, so producing only the electricity, but nowadays there is no waste to energy plant that works on producing only electricity, because most of them are used also for the district heating, for industrial heating, basically becoming the cogeneration plants, with some, of course, depending on the climate, go up to 80% of total efficiency. With each increase in limits in environmental limits, there is always some increase in the efficiency, and basically all the producers are competing to achieve the highest possible efficiency. Integration. So, the waste to energy plant is meant to be integrated in the whole waste management cycle, not as a separate or independent technology. With each lowering of the limits, we have technical drive for improvements. The Also, by that, the economic viability of the plant is increased. And basically, with each round, there is new drive to drive the development, drive the increase in efficiency, whether it is the environmental efficiency or energy efficiency. Uh, Waste to energy plant is part of the waste management, using basically the residual waste that cannot be recycled and the return according to the circular economy. It's not a separate stream and it's not lowering the results of recycling. It only helps to increase the potential for it. Normally, the waste to energy plant, this is one simplified block diagram. There is some fuel preparation on the input. We have a combustion. All of the plant are working with two-stage combustion. First stage, there is gasification or pyrolysis depending on the parameters, and then there is a second stage, complete combustion to ensure that there is no carbon monoxide in the flue gases. The flue gases go to flue gas scrubbing, which can be dry, wet, and to the stack. In the stack, continuous emission monitoring system to ensure that the emission limits are always within the given limits. Uh, we have in the boiler steam generation. The hot flue gases give energy to water, then which turns to steam. We have a turbine. We have a heat extraction for district heating systems, and of course, electrical energy from the generator. The residues from the plant, mostly it's bottom ash containing the inorganic part of the fuel of waste. And we have APCR, so air pollution control residues. Basically, those are used absorbent and fine dust from the flue gases. This is the simplified cycle. So we have water going to the boiler, producing steam. Steam goes through the generator, condenser, and returns back to the boiler. And on the other side, we have waste coming in, producing hot flue gases, which give the heat to in the boiler to the water, going through the flue gas treatment part and through the stack and emission control to atmosphere. There is various different kind of combustion and other technologies. I will shortly go through them. So we have a rotary kiln, which is very long on the market, very robust technology. It has a limited capacity, meaning the throughput and the energy output, and it's mostly reserved for hazardous waste because it can handle liquid, gas, solid particles, sludges. So it has its place in the waste to energy plants, but it's mostly used for hazardous waste. Regarding the rotary grate, it's almost never used for waste, so I'll skip it. Roller grate is a very interesting kind of grate, which is not fixed. Those are rollers, which transport fuel being combusted slowly over the grate. It's mostly used for some challenging fuels, which because the technology has a lot of moving parts and it's more complicated and prone to breaks than standard grate. Regarding the grate, grate is the most often used technology for waste to energy plants, and most of the plants in the whole world is functioning with a grate. Grate can be air cooled or water cooled. Each has advantages and disadvantages. Second most popular technology is fluidized bed. Fluidized bed Works very good. It's very compact compared to the Great. Can handle fuels with high calorific value. Uh, but the fuel has to be relatively homogeneous, meaning that the particles should be of similar size in order to function properly. Then we have plasma technology, which is mostly used in Japan. They're the only country having several plasma waste to energy plants. It's very efficient, but Japan is very far from the EU, and the technology didn't catch up in Europe that much. And then we have newer technologies, meaning pyrolysis, which work at the temperatures between 400 and 700 degrees, producing pyrolytic oil, which can then be refined to fuel. Or there is one, let's say, big potential for pyrolysis in order to use it as depolymerization technology for olefin extraction, olefin recovery. So, meaning it could work as a material recovery technology. But there are not that many plants and pilot plants that can operate in industrial required manner, meaning achieving more than 8,000 hours per year without significant breakdowns and problems. It's a promising technology, but still there is a lot of things to be developed and controlled. And gasification, especially the high temperature gasification at temperatures above 800 degrees, which can function very good because they're working without access to oxidizing agent, meaning oxygen from the air, with possibility of extracting hydrogen and carbon black as solid carbon particles, helping the reduction of carbon emissions and CO2 emissions in waste to energy plants. Regarding with each type of plants, what the future for the waste to energy is carbon capture. So meaning all the plants will have to introduce the carbon capture and storage or utilization because the CO2 emission tax will be increasing otherwise it will be increasing the cost for energy recovery from waste. There is also a possibility of integration of waste to energy with hydrogen production for synthesis of CO2 from the plants and hydrogen to produce e-methanol or e-methane or synthetic methane for other uses and industries where there is a necessity. For example, e-methanol is one of the choice fuels for ships and transport. New technologies and development also go to the plant simulation to predict the failures, weak points, to increase the amount of preventive maintenance, to increase the availability of the plants, of course, the throughput and energy production. Then second is to increase the amount of material recovery from the waste streams. We spoke about the bottom ash and the fly ash together with the use absorbents from the flue gas treatment, and some other hybrid types of waste to energy plants, meaning it could be used for heat only, for industry, which of course lowers the capex and could be a potential fuel substitute and energy source substitute for the industry. The next big part is society. So, technology, everything is logical, everything is solvable. You put enough effort and you can solve it. People, on the other hand, are not. So, the most problematic part of waste to energy plants is not they're not technical. It's sociological and very hard to go with it. Uh, Public is involved during the environmental impact assessment. Just excuse me for a second. And the whole process of environmental impact assessment uh, should ensure transparency, objectivity, and involve public participation. So everybody can be heard, everybody can ask questions, and everybody can give comments. It covers all aspects of the plant and the environment, and it gives feedback. It gives the opportunity for feedback, which is not always good. Uh, I will speak about so. Inside the environmental impact, there is some technical parts. Those are, again, very simple. If you need to reduce something, you find the technology, the costs increase, but it can be solved. Sociological don't work like that. Even if you solve all the technical issues and you ensure the best plant in the world, there is always a fear of the unknown and it never goes away. So those who are against rarely change their opinions. No matter who stands behind it, how the project is prepared, how the whole process is handled. Everybody is full of zero waste, everything can be recycled. Yes, that's true, but that would mean that everybody should do their own recycling. Once you put everything together, there is no way everything can be recycled. So the zero waste can work in very small communities, basically rural, how all the villages lived. There were no leftovers back in the time. But in the cities, it's basically not possible. One very concerning part in the during the process of environmental impact assessment is huge mistrust towards the institutions. That is something which is a big sociological problem, uh, especially in, let's say, lower developed countries or Central and East Europe, because nobody trusts the government, nobody trusts the institutions, nobody trusts the technical personnel, nobody trusts the environmental personnel. Basically, everybody just wants to screw you over. That's the whole background for it. So doesn't matter how many procedures you implement, how many mitigations and plant improvements you integrate, they won't work with that. They will shut it off. There is hundreds of different comments why it won't work like that. So basically, it created some effects which are very well known for not just waste to energy, but general waste management. NIMBY effect is very interested. So, yes, everybody recognizes it's their rubbish, but they don't want it to be handled close to them. They just want it to disappear. So it's not driven by technical issues. It's only driven basically from fear and from the unknown. When we are speaking about the effects, there are always social, political dynamics in each country, in each local community. You always have somebody pro the projects, against the projects. The worst thing is that although you somebody thinks that it's a good project, they will kill the project just because it's not their project, it's somebody else's project. Why? To gain some political points, because of some publicity. NGOs. Unfortunately, from my experience, they are mm, not partners and they are not willing to communicate. Not sure why, because if basically something is solved, then there is mm, they're probably afraid that there is no space for them anymore if everything is good. So they need to create a new problem instead of helping to solve some existing. The comparisons on the during the public presentations on environmental impact assessment are wild. So we really need to witness and go to the those presentations in order to comprehend how it looks like. And it doesn't matter how good the answers are, how good everything is put together. It's never okay. Uh, Other only fear because of the lack of knowledge and understanding. Yes, there is a whole hierarchy, and the waste to energy is not competing with recycling. It only helps to reduce the amount of landfilling and to use the only useful property before the landfill, and that is energy potential. Uh, but it's something that it's very hard to explain. The only way how to reduce the problem is to develop a project properly from the start, to have an open communication, to start the whole transitional process. So basically, when it hits the light and the environmental impact assessment, everybody is just eager waiting for it to happen because it's properly communicated, it's well prepared, everything is transparent. Of course, it's not just uh, willing to be transparent, meaning that also political influences. It cannot be uh, political gain. It's something which it should be society's step forward. So, without proper preparation, most of the projects are unfortunately failed, this destined to fail. The last important part in the waste to energy part, financing. Uh, Unfortunately, the EU financing for the waste to energy for energy recovery of non-hazardous waste is closed through the EU taxonomy for sustainable financing, but some other sources emerged. So PPP is a good model for waste to energy because it can integrate very well the local community and the financing and the most often operating partner for such plants. Uh, the biggest financial risk is always inactivity and delay. We have witnessed in the last eight, 8 years, 7, 8 years, that the cost of construction of waste to energy plants has more than doubled for small plants, increased almost double for the bigger plants, and the cost for energy recovery from waste on the market has increased more than 3 times. Meaning, if we had acted 10 years ago and built the plants, our plants would have been paid off till now. So, with each delay, we are not, we can be closer to perfect and optimal technology, but we are 2 steps further from it to be financially viable in medium term. Uh, For the waste to energy plant, and for it's an infrastructure project. For the infrastructural projects, we are those are built for the future. Those are not built to be commercially viable, payback in 6, 7 years. Everybody happy, and let's go on. And the capex is not the point that kills the infrastructural projects. It's OpEx. Uh, the problem is that with time passing by, the capex is increasing, meaning that the OpEx needed to cover that needs to increase also, and that's politically not good thing. So with time passing by, we are all only step by step further from waste to energy plants, but not because of the necessity and better technology, but only because it gets more and more complicated, more and more expensive. Uh, in order to understand why the OpEx is very important because of the income structure of the typical waste to energy plant, gate fee, meaning uh, it's not fuel. You're not paying. Somebody else is paying to you to do the energy recovery, and it accounts the gate fee for energy recovery, it accounts for 60 to 75% of the total income of waste to energy plants. Only 25 to 40% depending on heat, of course, of the revenue comes from the energy sales. I pulled out a few examples of waste to energy plants across Europe, especially those which are in urban areas. So, Celje in Slovenia, the plant was built 2008, 2009. The idea and the preparation of the project started early 2000. It took them 8 years to finish the whole process to build the plant. The urban area surrounded it was on the edge of industrial area, but the urban area now surrounded the plant. There were no complaints at all. They are very transparent in operation. They are housing the visits from schools, from universities. So it's a very good example of waste to energy plant. They went through 2 steps of modernization also, which is normal because the plant is a live thing. You need to invest, you need to adopt, improve. You always see some possibilities of improvement. Copenhagen is a very famous one, Copenhagen, with the ski slope on the waste to energy plant. Of course, you need to see the difference between the Celje plant and the Copenhagen plant, of course, and Vienna plant. The excess funds for the architecture. So you have a more industrial style plant, and you have plant which is very, very interesting, very, very nice. It always depends on the possibility of financing because it serves the only purpose is sociological acceptance and to improve the visual perspective of the surroundings. And of course, the famous Spittelau in Vienna, which is marvel. You have to understand that the Spittelau on that place was built in 1970s. They went through 5 major upgrades and changes on the same location, and it's still working today. To conclude the first part, as I said, technology is simple, society is complicated, financing is solvable, but we all the most energy need to be addressed in the sociological part and the communication part, and of course, it's most often forgotten about. The other part is land use, planning for increased carbon absorption, rough agenda for the topic. So, uh, the land use planning is often seen as a zoning exercise, but it has a big possibility to be a climate instrument. With every planning decision, where to build, how dense, how green, we can determine how much CO2 we can emit or absorb. Cities and rural areas must be viewed as a one functional carbon system. The more connected energy waste spatial strategies are, the faster we can move towards the neutrality or even carbon negativity. Uh, Urban form is a dense, populated area. Mixed-use cities emit less, uh, move smarter, and absorbs more. With the densification of the city, we can save resources, and while a smart city can make climate adaptation visible. The real transition happens at the street level, where mobility, greenery, and community intersect. Uh, in order to have good uh, functioning cities and carbon and the way to carbon neutrality, all systems need to be efficient. From the heating, from transportation, and of course, we'll come to that, uh, green zones. Uh, it's very popular to have a too high urbanization of areas, which now present closed loop with increased problem amounts, with too much traffic, without enough green. We have heat islands. We have a problem with emissions. So it's very important uh, to properly plan uh, the development of the cities. On the other hand, we have a rural area where we have basically forgotten about because everything is functioning and working around the cities, and there is a lot of rural areas which can be adopted in order to compensate and to help the mitigate the problems we have in cities. Uh, by doing that, we can increase the biodiversity. We can help the surrounding areas of the landscape to adopt if we manage it properly. Land use is now embedded in land use planning is now embedded in multiple EU frameworks, from biodiversity to energy. And of course, the key is to integrate all of it, overlapping all the mandates into the unified local plans. Cities can leverage those frameworks for funding and coherence. Of course, we should not forget about the Sustainable Energy and Climate Action Plan and Integrated Climate Energy Plan. About the co-benefits and local impacts. Basically, that's where carbon meets the community. The green land delivers multiple paybacks. A park can be a carbon sink, a social connector, and an economic driver at once. And this is why municipalities must evaluate not only the CO2, but also the other co-benefits when designing land policies. The good examples in planning are intensive forestation in Helsinki, in Finland, and they have conducted studies that it takes around 14 years for each planted tree to become a carbon sink within the city. Of course, Budapest and is very green, and they have a lot of urban forests. In the energy transition, we often talk about technology and infrastructure, but if a land quietly does half of the work by capturing, storing, and stabilizing carbon, the power of planning is in coordination, connecting waste, energy, transport, and land so every square meter works for the climate goals. Our cities and regions can become carbon positive ecosystem if we plan intentionally and measure what matters. And we don't need new land. We need a smarter way to use a greener place where we live and more integrated land in use. In general, final conclusions from both of the topics. We have spoken about the technology part from waste to energy, about the sociological aspects, financing aspects. We have spoken about urban and rural areas working together as one carbon ecosystem, and a lot other topics. And with this, of course, links and everything to the website. I've come to finish with the presentation. I hope you enjoyed it, and we can use the remaining time for Q&A if you have questions.
Perfect. Thank you so much, Vaska. Perfect timing. I didn't even have to worry about it. It's just very well thought through. Thank you for your presentation. I really liked that you connected technical parts and social aspects because indeed, convincing public that this is the way to go and this is safe and you should trust us can be very challenging, not only for like local politicians, but also for smaller initiatives when it comes to waste to energy and waste sorting and you already touched upon it a little bit that the best approach how to kind of talk to public is when you start this process as early as possible. Can you talk a little bit more about it? What's the best way to approach it? Like, is it should the initiative come from like local government, or it can come even from like higher up
Uh,
politicians? So, what's your experience? Please share.
uh, it both. So, I was involved in environmental impact assessment for one waste to energy plant in the city near Zagreb. Uh, they started very early. They had a dozen of public presentations. It's a private project, so it's a private company working in waste management. They started very good. During the environmental impact assessment, it was during the COVID time, so I cannot judge whether the low interest came from uh, good preparation or general lack of interest because it was COVID time or it was held online. Not a lot of people are willing to, let's say, it's a social event. Normally you have 200, 300 people, very loud when you have such a public presentation, especially if there is some publicity behind, especially negative, of course. But during the COVID time, there was 20 or 30 people participating during the presentation and Q&A during the public presentation. There were few hundred of, let's say, questions, complaints during the feedback process. So it was well prepared, but I cannot judge uh, uh, about the public involvement because of COVID. But on the other hand, The other project was hazardous waste incineration plant for medical waste for the largest medical hospital in Croatia. Of course, the plant was inside the land plot of the hospital and in the center of the city. So let's say it was pretty wild. There was more than 300 people coming to the public presentation. The public presentation and Q&A lasted for 6 hours. So that's why when I was given the opportunity to talk, I had to talk most about the social aspects for waste to energy because on the end of the day, as I said, technical part can always be solved, but the sociological part, not that easy.
Thank you. Very insightful examples. And yeah, that's amazing that you have kind of like experience on both sides of the spectrum here.
Yeah.
Um, we basically have like last 4 minutes. If anyone has any questions, that's the great chance and opportunity to ask Vasco right now. Um, I just wanted to say that I liked that you brought examples not only from like developed and advanced Western Europe with like fancy examples of waste to energy plants, but also from Eastern Europe, and just to show that there are different initiatives all over Europe. We are all doing our best to, to design new solutions for safer future and safer tomorrow for us all. I think this example that you brought up from Copenhagen is pretty well known. I remember when the plant was built and there was still some kind of like public concern that is it safe to be this close to this plant? But I feel like them designing the building in a way that it encourages and invites people to actually interact with it, to go skate on this hill and chill in the sun. And there are so many different zones. It actually invites the public and it makes it feel more safe. Like you start thinking that, okay, I mean, if they built it, it must be safe, right? So it kind of like, I feel like it's a good example of kind of combining both of this technical things and technical solutions and social perspective of persuading public that it's safe. So thanks a lot for mentioning it today. And yeah, I think we will maybe slowly wrap up. So if you have any follow-up questions to Vasco, please, you have my email contact. Just drop me an email. I will get you guys in touch. Otherwise, thanks a lot for joining us today. Thank you, Vasco. It was very interesting. And I'm wishing all of you a nice day.
Okay.
And see you next Tuesday. Please join us.
Thank you.
Thank you.
Thank
Bye.
you, Vasco. Bye.
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 Bye.